Okay, let's go ahead and work on the review for the 4.1, 4.4 tests we're going to have next class. Number one, determine two coterminal angles, one positive and one negative, for when theta is equal to 5 pi over 6. So if we're looking for coterminals, we're going to add 2 pi, which instead of writing 2 pi, I'm going to write 12 pi over 6, which gives me the 17 pi over 6. That's one of my answers. And to find the other coterminal angle, we're taking 5 pi over 6 and we're subtracting 12 pi over 6, which gives us a negative 7 pi over 6. One positive, one negative. Number two, determine two coterminal angles for one positive, one negative, for theta when it equals negative 125. So we're going to take negative 125. We're going to add 360, and that's going to give us our positive 1. I'm going to use a calculator just to make sure I don't make a mistake. So we've got minus that. Okay, and that gives us a 235-degree angle, which is positive. And then we're going to find the other one. We've got negative 125 minus 360, which gives us what? A negative 485-degree angle, and that's our negative angle. Number three, find the complement when theta is equal to 42. So complementary angles add up to 90. One way to do it is like what we did in class, to say that 42 plus another angle equals 90. And then we'll go ahead and subtract 42 from both sides. And we'll get, what, 8 or 48? Does that sound good? Another way, a little bit shorter to do, is just to say 90 minus 42 is 48. So 48 is our complement, and our supplement is when we have one angle, to find the supplement of that angle. We're going to go ahead and add another angle so that their sum is 180. And we would subtract 42 from both sides. So we get 180 minus 42, which gives us what? 138. And so that is our supplementary angle. I could have just taken the 42 and subtracted it from 180 to find the supplement of 42. Okay, the terminal side of the angle theta, if theta is equal to 11 pi over 7, is in which quadrant? Okay, we're going to go straight to thinking about our four quadrants and thinking about, when I talk about an angle like 11 pi over 6, I start to think about, well, you know what, 11 pi over 7. 11 pi over 7 is just short of 14 pi over 7, right? If I had 14 pi over 7, I would hoop all the way around to 2 pi, right? Because 2 pi is the same thing as 14 pi over 7. But I'm 3 short, so I'd have to back it up, 3 pi over 11, and I'd end up right about here. This would be 11 pi over 7. I'm not sure what I just said to back it up. I really meant to back it up 3 pi over 7. I'm not sure if I said 11. So 11 pi over 7 is in the fourth quadrant. If you weren't sure of that, you could think about splitting up the, using the quadrants. You could think about splitting up the first two quadrants in sevenths, since our pi would be 7 pi over 7. That would mean we'd have 7 equal parts, which basically means we'd have what? 1, 2, 3. So let's see, 1, 2, 3 and a half. So then we'd get like kind of like a half here. I'm not sure if this is going to help us at all. Let's see. 1 pi over 7, 2 pi over 7, 3 pi over 7, 4 pi over 7, 5 pi over 7, 6 pi over 7, 7 pi over 7. Yeah, that actually did help. So we could do the same thing if we wanted to keep going all the way to 14 pi over 7. We could say that we've got, let's see, 8 pi over 7, 9 pi over 7, 10 pi over 7, 11 pi over 7, 12 pi over 7, 13 pi over 7, and 14 pi over 7. So if we're looking for where 11 pi over 7 is, it's right here. 11 pi over 7. So that was just another way to think about it. Choose your way. You could even probably come up with a third way to do it, but ultimately it is in the fourth quadrant. Okay, use your calculator to evaluate cosecant of 4.1. The first thing we're going to do is realize 4.1 is a radian. There's no degree there. So the first thing you want to do is look at your calculator, put it into radian mode, hit enter, clear. Okay, and the second thing I'm going to remember is cosecant is the flip of sine. So in my calculator, I only have sine buttons. I don't have cosecant buttons. So in my calculator, I'm going to put 1 divided by sine, and then put my 4.1, and I get negative 1.22. That's good enough. All right, so evaluate means, in this case, using your calculator to evaluate. So number 6, use your calculator to evaluate cotan of 34 degrees and 27 minutes. So same thing, there's not a cotan button, but there's a tan button. So in our calculator, we're going to put this, and as we'll go ahead and put 1 divided by, then we'll hit the tan button, and then we have to remember, oops, you know what? I've got to get back. I'm going to hit my mode and get back into degree mode, because we are using degrees now. That's really important to keep up with which mode you're in, whether it's radian or degrees. So now I'm going to do 1 divided by tan, and then 34 degrees. So I'll put the 34 in, and then I'll hit second angle, hit enter to put a degree in there. Then I'll put the 27 in, hit second angle, and I'll put the minute in. So now I have on my calculator screen the same thing that we have here. I hit enter, and I get 1.45. You could put 1.46 because it really is 1.457. Your choice. Okay, so number 7, if secant theta is equal to square root of 85 over 7, find cosine of theta. So in this case, square root of 85 over 7 is not a unit circle answer. So we know right away we are working in the right triangle. We're going to do right triangle trig. And basically in this right triangle, in this crazy crooked right triangle, we've got theta, and it tells us secant theta is equal to square root of 85 over 7. But the problem is that we know SOHCAHTOA so well does not include secant. So secant, we have to remember, is the flip of cosine, and we know cosine theta is going to be adjacent over hypotenuse. So then we know secant theta, since it's the flip, would be hypotenuse over adjacent. So when we look at this, we look at the square root of 85, we know that's the hypotenuse. So I'll put that here. And we see the 7, we know that that is the adjacent. So really quickly, oh, here I am. Okay, so here I am doing all this, and I really didn't stop to see how simple the problem was. Yes, we could keep doing what I'm doing, which is cosine is adjacent over hypotenuse, which would be 7 over 85. I thought they were going to go ahead and ask us for other things. Apparently not. So we could have just backed it up and not have to do any of that. Let's go ahead and rationalize the denominator. Okay, but I didn't realize that this one really is just flip it. Flip it. Know that if secant's positive, cosine's also positive. You didn't need to do any of that right triangle stuff, but that's okay because you probably will have to on the next problem or two. It's always good to practice. Okay, use the fundamental identities to determine the simplified form of cotan x, secant x. In this case, when you want to simplify, your best strategy is to change everything into terms of sine and cosine. So when I see cotan, I know that cotan is cosine x over sine x because I have memorized my identities, right? I know you have too. So secant x is the same thing as 1 over cosine x. Because we just have multiplication going on here, we can cancel out cosine x, which leaves us with 1 over sine x. And 1 over sine x is cosecant x. So it's pretty cool to think that this is the same thing as cosecant x. It's like cosecant x in disguise. That's pretty fun. Okay, use the trig identities to transform one side of the equation into the other. I'm going to write this a little bit bigger so I can carry things down. I'm just rewriting the problem right now. Okay, here's the deal with this. When they ask us to prove or they ask us to transform, they are really saying, pick one side and work with it and carry the other side down. Obviously, we're not going to pick one and work with it to try to make it look like the left side. That would be kind of crazy to do. We're going to carry this down, and eventually we're going to be able to write one again. So we're going to work on the left side and try to make it look like the number 1 that's on the right side. So here we go. The only thing that I can turn to on my identity sheet that has sine squared in it is sine squared theta plus cosine squared theta equals 1. So that's the only thing I can turn to, then I'm going to use it. And I noticed, wait a minute, if I went ahead and subtracted sine squared theta from both sides, look what I would get. I would get cosine squared theta equals 1 minus sine squared theta. 1 minus sine squared theta. I wonder where we've seen that before. So basically, this equal sign says that cosine squared theta is the same thing as 1 minus sine squared theta. And so just like when we did geometry proofs, we're going to use substitution. Instead of writing 1 minus sine squared theta, we are going to write cosine squared theta. Did we do anything to the bottom? Nope. We just were working on the numerator. And so our last step, what is cosine squared over cosine squared? It's 1. Don't make the mistake of just because they cancel out, don't think that they're gone, because basically when we cancel out, we're saying cosine squared theta goes into cosine squared theta how many times? Once. Cosine squared theta goes into cosine squared theta how many times? Once. So that's why we end up with 1. We'll finally carry this 1 down, put the equal, and I like to put a check. Okay, solve for x. This problem is just going to lead me right to the solution, because basically what they gave me is they gave me an angle, they gave me the opposite side, and they gave me the hypotenuse. And when I see opposite and hypotenuse, I know we're talking about sine. So they gave me sine of my 70-degree angle is equal to 23 over x. So now we have an equation with only one unknown. What I want you to do before you pick up your calculator is isolate x so we know exactly what we're putting in the calculator. In this case, what I would do is I would put a 1 underneath sine of 70 degrees so that you can cross multiply. And when you cross multiply, you get x times sine of 70 degrees equals 23. And then you're going to divide both sides by sine of 70 degrees. And so x equals 23 divided by sine of 70 degrees. Now we can pick up our calculator. Note that we are in degree mode, so I'm just going to double check my calculator that I'm still in degrees, and I am. So I'm just going to put in 23 divided by sine of 70. And I get 24.47. I could round up to 24.5. I'm not going to be real picky on this. Does it say even what to round up to? Let's just do 2 terms or 2 places after the decimal point. So let's do 0.48. Once again, don't worry if you wrote 0.47, you will not get points off. Okay, a 10-foot ladder leans against a wall 7 feet above the ground. What's the angle formed between the ladder and the ground? Okay, so a 10-foot ladder. Let's see, we love to draw pictures, at least I do. So here's our wall, and our wall is 7 feet. And then our ladder is leaning against the wall, and it's 10 feet. Well, kind of, okay, picture not drawn to scale. That looks way bigger than 10 feet. And so then, of course, we have the ground. We'll make the ground green. Okay. And it says, what's the angle formed between the ladder and the ground? So we're talking about this angle right here. So we just look at what they've given us. They've shown us what angle we're looking at. and they've given us the opposite and the hypotenuse. So opposite and hypotenuse, that's sine. So sine of theta equals 7 over 10. Okay, whenever we don't know the angle, what we do, we know the answer instead, we use inverse sine. So we know theta is going to be equal to inverse of sine inverse of 7/10. So we're going to go ahead and put that into, just think about it. This says the sine of what angle is equal to 7/10. And that's what inverse does for us. It finds the angle whose sine is 7/10. So let's go ahead and use the second button to do the inverse sine. We'll put in 7 divided by 10. And we got 44 point, oops, 43. Okay. Okay, in right triangle, if cosine theta is 2/5, find the other 5 functions of theta. So let's go ahead and do this. This is an interesting problem, and we'll talk about why it's interesting in just a second. We know that 2/5 is not a unit circle value, so we go straight to triangle trig, right triangle trig, where that's our theta, that's our 90-degree angle, and cosine is adjacent over hypotenuse. And then we realize too that to find all the 6 trig functions, or the other 5, we're going to need to do the Pythagorean theorem. So we'll have 4 plus x squared equals 25. So x is going to equal what? Square root of 21. All right, so we'll put square root of 21. Then our right triangle is good to go, but usually what we're asking ourselves is, what quadrant are we in? If it doesn't give you any hints about what quadrant you're in, because we know if cosine is positive, technically there are 2 quadrants that cosine could be in. Cosine could be in the first quadrant or the 4th quadrant. Since it didn't give us any other information, we are assuming that it's in the first quadrant. So if that happens to you on a test, you're assuming that it is in the first quadrant. All right, so here we go. Sine is opposite over hypotenuse, so that's going to be 21 over 5, and everything in the first quadrant is positive. We don't have to worry about our SIGNs. Our tan is going to be opposite over adjacent. Our cosecant is the flip of sine. Then we're going to want to rationalize that to be 5 root 21 over 21. Secant is going to be the flip of cosine. They already gave us cosine as 2 over 5, so secant is 5 over 2. And then cotan is a flip of tan, which gives us 2 over root 21. And if we rationalize it, it gives us 2 root 21 over 21. That's all you'd have to do for this one. Doesn't seem too bad so far. Let's see. If sine theta is less than 0 and tan theta is less than 0, what quadrant is theta in? This is an excellent one. I think anytime we talk about the quadrants, we really do have to think. So when we see that they say sine theta is less than 0, another way to say that is sine theta is negative. And let's stop and see, where is sine theta negative? Well, let me go ahead and pull this. Sine theta is negative in this quadrant, and it's negative, so in the 3rd quadrant, and in the 4th quadrant. And then it tells me that tan theta is also less than 0, which means that tan theta is negative. So where is tan negative? Well, not in the 1st quadrant, because sine over cosine, that's positive over positive. How about in the 2nd? Ooh. How about in the 2nd? Oh no, it's not gonna come with me. Oh no. All right, that's okay. Go ahead and erase that. All right, so it was a good little gimmick until it fell apart. So tan theta is going to be negative in the 2nd quadrant, where sine is positive but cosine is negative, and tan is also going to be negative in the 4th quadrant because cosine is positive but sine is negative. So it says if sine is negative and tan is negative, what quadrant are they in? Is theta in? Well, the only quadrant that both of those things happen is in the fourth quadrant, which is your answer, the fourth quadrant. All right, given that tan theta is negative 12 over 7 and cosine theta is less than 0, find cosecant theta. Lots of stuff right now. I don't know if you've noticed, but we have two things going on. And this is really, really interesting. I want to go back just for a second. It's almost like the test really is, the practice test, the review, really is taking us down from the 4.1 problems all the way through, just progressing. Because when we look at 12, all we had to do was write triangle, and we didn't have to worry about the quadrant. And then in 13, they're kind of reminding us, oh, that's right, we've got this quadrant thing, and that's going to be really important. And then in 14, they put the two together. So we can see that 12 over 7 really is not a unit circle, so it's not a unit circle, it's right triangle trig. But let's go ahead and look at the quadrants real quickly, because here you see that tan is negative. And once again, we know that tan is negative in the fourth quadrant and in the second quadrant. And then they also give us that cosine is less than 0, which means once again that cosine is negative. Well, where is cosine negative? Cosine's negative in the second quadrant and in the third quadrant. So where are both tan negative and cosine negative? They're both negative in the second quadrant. So the reason why I did the quadrant first is that really helps us to know which quadrant we're in, so that we know what the SIGN, those kind of signs, are for each of our answers. So here we go. Now we can make our right triangle and do some right triangle trig. I'm going to ignore the negative because that negative already told me what quadrant I'm in. So tan is opposite over adjacent. So I've got 7 and I've got 12. Let's do Pythagorean theorem real quickly. We'll have what? 49 plus 144 equals x squared. So I'm going to pick up a calculator. Let's see. We've got 144 plus 49, 193. I don't know if anything's going to come out of that. So this, obviously it's not a perfect square. So x is going to be the square root of 193. Hold on. Let's see. Okay. So square root of 193, and then I'm just going to go ahead. I'm just going to find cosecant. So cosecant is a flip of sine. If sine of theta, because this is our theta, if sine is 12 over 193, then cosecant theta is square root of 193 over 12. And once again, since we're in the second quadrant, sine is positive in the second quadrant, so cosecant would also be positive. And that's that. One wasn't that bad. Okay, find the reference angle for theta equals negative 200. So first we have to remember that negative angles, we find them by going clockwise. So what this means is this. If I go around, if I start at the initial side, which the initial side's always here of an angle, and I start going clockwise, so in a negative direction, and if I stop here, I know that I've gone 180 degrees in a negative direction. So I just need to go, what, 20 more. So there's my, right here, is approximately my negative 200 degree angle. But they're asking for the reference angle, and basically the reference angle is just a positive measurement of how far the terminal side is from the closest x-axis. Meaning, in this case, here's my terminal side right here. How far is that away from this part of the x-axis? So it makes sense that if we were going 180 and then had to go another 20 to make it to negative 200, then we know that that measurement right in here is 20 degrees. That's my reference angle. Now, where does 20 degrees really lie? I mean, 20 degrees really does lie here, okay? It is in the, and once again, these are not drawn to scale. 20 degrees is in the first quadrant. All reference angles will be in the first quadrant if you want to graph them. But a real easy way to think about reference angles is the positive measurement of the terminal side away from the closest part of the x-axis. All right, so that gave us 20. Find the reference angle for 7 pi over 6, and then give cosine of theta. So here we go. Once again, we're going to look at our quadrant, and 7 pi over 6, when I think about it, if I go 6 pi over 6, that would be, if I start once again, right here, that's always my initial side. And if I went 6 pi over 6, I'd almost be to 7 pi over 6. I'd have to go 1 more pi over 6, and then what you would see would be the 7 pi over 6. But a reference angle is, hey, how far is this terminal side of the angle away from the closest side of the x-axis? So it's saying, hey, what's this measurement here, and give it to me positively. So we know that if we already went a 6 pi over 6, and then we had to do an extra one, then our extra part, the measurement is pi over 6, and that is our reference angle, pi over 6. So let's see, they'd want the pi over 6 here. Be really careful because you might get tricked if you saw this on the test, because this is cosine of theta. Pi over 6 is not theta, okay? 7 pi over 6 is. So we think about it, we do say to ourselves, hey, what is, here's pi over 6 in a positive direction, and we know that these are our coordinate points for pi over 6, and it's asking for cosine of this. So we could put root 3 over 2, but then we remember, wait a minute, we're really in the third quadrant where cosine is negative. So our answer is going to be negative root 3 over 2. All right, if the point 3, negative 4 is on the terminal side of an angle in standard position, find requested trig values. Okay, so let's look at this. When you think about, some people were drawing the triangle in class wrong, so let's talk about this. When you think about this point 3 comma negative 4, if you graph this, you'd start at the origin, you'd go over 1, 2, see if I can do this correctly, 3. So you'd go over 3, and then to get to the point, you'd go down 1, 2, 3, 4. Once again, not drawn to scale. So we go down 4. So we have our triangle where this side is a 3 and this side is a 4, right? Our theta is always going to be the terminal side touching the initial side. So our theta is always going to be here. Now, if you can work like this, then you don't have to worry about what quadrant you're in. You would just go ahead and say, even though this truly, the measurement is 4, it is in a negative direction, and you could put the negative 4, and you could fill all of this out. Let's see, sine of this is going to be opposite over, oh, we got 3, 4, 5, so we're going to put a 5. But you know, if you do this, you're kind of like, wait, is 5 positive? So some people are doing it, and let's see if it will work. Sine is opposite over hypotenuse, which is negative 4 over 5. Tan is opposite over adjacent, which is negative 4/3. And secant is, let's see, cosine would be adjacent over hypotenuse, and secant would be the flip. So that would be 5 over 3. So let's just double check our SIGNs. Sine is negative in the fourth quadrant that we're working in, so that looks good. Tan is negative in the fourth quadrant, and secant is positive. So that's one way to do it. The other way that I do it is I recognize, yep, my point's in the fourth quadrant, so I'm in the fourth quadrant, and then I redraw my triangle. But I'm not sure if that's helping too many of you, but if it is, you redraw it in a way that you can see that your opposite side, oh, this is definitely not drawn to scale, sorry about that. Your opposite side is 4, your adjacent side is 3, and your hypotenuse is 5. And you would go and do SOHCAHTOA with that. Okay, if cosine theta is equal to 1/2, find two solutions of the equation. So I think this stumped some people because they weren't thinking about this as an equation. But yet, here's the equal sign. This is an equation, and it does have just one unknown variable. That's the angle theta. And they want us to solve it. So if you're going to be one of those people that does your unit circle, which as you can see, we haven't used the unit circle all that much so far. A little bit here, a little bit there. A lot of quadrant going on of knowing what's going on in the quadrants and how to find angles. And so that's somewhat related to the unit circle as well. So here we go. I would just take a look at my unit circle and remind myself, where's cosine equal to 1/2? Well, I know for sure at pi over 3, cosine is 1/2, right? While sine is root 3 over 2. And I think about what other quadrant is cosine positive. And cosine is also positive in the fourth quadrant where we have what? 5 pi over 3. At 5 pi over 3, we have 1/2 and negative root 3 over 2. So when they're saying cosine of what angle is equal to 1/2? Well, cosine of this angle and cosine of this angle. Now note, I worked in radians because you just work in radians more as you get into the more advanced math. But you could have worked in degrees. It didn't ask you for radians. So instead, you could have put what? Pi over 3 is 60 degrees, and 5 pi over 3 is 300 degrees. So you could have put 60 and 300. You could have done that. But they're looking for two places where two angles that have a cosine equal to 1/2. All right, 19, name an angle between 0 and 360 with the same cosine as 140. So they're basically, once again, this is the unit circle. It may not be dealing with all the root 2 over 2s and root 3 over 2s and 1/2, but it is dealing with the unit circle. So it's saying somewhere between 0 and 360, let's find 140. So I think about that, and I think, well, 140, when I think about it, is I can go all the way here, that's 180, and then have to back it up 40, right? Does that make sense? So basically, this right here is your 140. And we had to back it up, right? 140, and then another 40, we would have hit the x-axis again. So once again, this is about knowing about what reference angles mean. So right here, I see my reference angle. Once again, it's always the terminal side of the angle and the closest side of the x-axis. What this angle measures as, that's your reference angle. So that angle measures as 40 degrees, right? Because 140 plus 40 is 180. And so when I start to think that way, I'm like, oh, I need to look at all my bow ties for 40 degrees. I know it's not a unit circle bow tie, but we can still use that, that little method to help us. So I'm going to look at all the angles that are 40 away from the x-axis. So let's think about the, so we've got all the angles, let's see, and we're in degrees, so let's just stay in degrees. We know this one's the 140 degrees, this one's obviously 40. This one would be 360 minus 40, so that'd be 320. This would be 180 plus another 40, so that'd be 220, right? Okay. And so now that I have all my bow tie angles set up, I need to think about what is the cosine of 140. Now, I don't know the angle. I don't know the, sorry, I do know the angle. It's 140, but I don't know the answer. But I do know that the answer is going to be negative because cosine is negative in the second quadrant. And 140 is in the second quadrant. Where else is cosine negative? Cosine is negative in the third quadrant. So out of the remaining three angles, 220, 320, or 40, who else is going to have a cosine that's negative? Well, the only one that does is the cosine of 220. So 220 wins, and that's your answer for 19. Let's look at 20. Given that cosecant theta is undefined, and theta is being held between pi over 2 and 3 pi over 2, find the values of the 6 trig functions of theta. So let's see. So let's start with what they gave us first. Cosecant theta is undefined. So to remember, hopefully you remember how to think about this. Cosecant theta is the reciprocal of sine theta, so we can rewrite it like this. And when we talk about something being undefined, that basically means we've said, hey, their denominator equals 0. If you want to be undefined really fast, make your denominator equal to 0. So here we go. If your denominator is equal to 0, we'll have sine theta equals 0. And then we'll have to stop and go, well, where does that happen? Well, let's look at the unit circle. And remind ourselves that here at 0 and 2 pi, and here at pi, sine is going to be 0, right? For here, the measurement or the coordinate point here is 1, 0, and here is -1, 0. So these are the two places, both at pi, 0, and then if we went around again, 2 pi. But they told me that theta is between, it's less than or equal to pi over 2, and it's greater than or equal to 3 pi over 2. So basically it's saying it's somewhere between this angle and this angle. The only angle that's in between, that's included in that parameter, is pi. So we found theta. Okay. Once you find theta, then you just take it away. So once again, we use the clue that cosecant theta is undefined, and we use that to understand that our answer, our theta, is either going to be pi, 0, or 2 pi, and that this part of the question helped us to realize, oh, we just couldn't use pi. So then we're going to go ahead and look at pi. So let's see. Sine of pi, sine matches up. Oh, we already knew sine of pi is 0. Cosine of pi is -1. Tan is sine over cosine, that would be 0. We already know cosecant would be 1 over sine, and that's undefined. Secant's 1 over cosine, so 1 over -1 is just -1. And cotan is cosine over sine, which would also be undefined because cosine over sine would be -1 over 0. You cannot have a 0 in your denominator. So that's it. I would suggest, if you want to do this again, to practice on different problems in your homework, definitely memorize everything that you need to know, and just really get a feel for what this practice test is identifying as important to get ready for this test, and focus on those things. All right, I know you guys can get a great grade on this. Study, and I'll see you in class.